Good morning and welcome to July 1st. And we are going to look at machine learning. I think the other time I read your comments, you guys were really off when I was trying to deal with some modules. So I believe in today's lecture, I'll try to do some bit of theory for 15 minutes to let you understand what is done than doing the work. Then we will do it practically and write the codes with a simple problem. The number is still dropping. That's very bad. You had a whole weekend to prepare for today's lecture. I don't know why you guys, anyway, kids these days, I will call you kids these days, don't mind. But you wait after next week when I give you the project. You will learn the hard way. So today, we're going to look at machine learning. And when you're looking at machine learning, there are so many concepts that are out there. But the most important thing is to know the types of machine learning. You need also to have some basic terminology of machine learning. One of them is a data set, which I believe you're quite aware. One of them is label data, unlabeled data, training, testing, scaling. All these are common languages that are being used in machine learning. But the most important thing is data splitting, train, test, split, cross-validation, the exploratory data analysis, all this feature engineering, module selection, normalization, all this you need to understand them. But what is now exactly machine learning? Because when you try to understand machine learning very well, you will know that machine learning is into three categories. There's what we call supervised learning algorithms. Okay, let's first get to understand what machine learning is all about with the definition. Now, machine learning is a subfield of artificial intelligence. It focuses mainly on development of algorithm and statistical modules that enable computer to perform tasks without explicit instruction. Instead of the system learning from, it makes the system learn from data to make decisions. And this can be in terms of learning from patterns or learning from data to make predictions. So with supervised learning, you realize that we'll be explaining more on the prediction. With unsupervised learning, we'll be talking about learning from patterns, consumer behavior, how you buy goods. Those are how we will be focusing on. Now, the other important part that I want to focus so much is when it comes to, I think I've been able to talk about the, the kind of machine learning that we have, okay? There's what they call supervised learning and unsupervised learning. So take note of that. Maybe if you're going to take some bit of notes, then you can try also to write it in your notepad because that's what you should be focusing on. You can have what we call the types. This is not my focus, by the way, for now, but we'll look at, I don't want to make assumptions. is what we call supervised learning, and another one is called unsupervised learning. Now, we're going to also have what we call reinforcement learning, but I think for the purposes of time, we might not do some neural networks, but we'll have reinforcement learning as types of machine learning. Now, before we get into the actual things that we are doing, most of you are interested so much um, into how do we deal with machine learning. So there's something that I want you to take note of. It is called data pre-processing. Now, when it comes to data pre-processing, I want you to always be very keen that we have so many sources where we can maybe do a little bit of data collection. But we did a little bit of data collections together when I was trying to collect data from you, and you have that data. So the process of gathering raw data is very challenging. You can build system where you collect those data. And we also need to do some bit of web scraping. I've not shown you web scraping, but I will be able to show you maybe in the last week when we are doing web development. Web scraping is using Beautiful Soup. It's a very good concept of collecting data. Now, there are some challenges that are there when you try to collect data. We were together when we were trying to do this. There's a lot of issues with data quality, and those data quality comes with wrong format, wrong data, empty cells, and duplicates. Now, you know that. And now the most important thing that I want you always to remember is, maybe I'm going to try to put a little bit emphasis right now, but I want you to know that whenever you're going to do your final project, you're going to have duplicates, you're going to have, please listen to me carefully so that it helps you. You're going to have wrong data, you're going to have wrong formats, you're going to have duplicates, you're going to have empty cells. But I need you to be very keen and learn how to work with that data set, which you're going to get next week. It's going to be a little bit complicated compared to the one in class, but you need to know how to do what we call data cleaning. So when it comes to data pre-processing, okay, data pre-processing, please try to understand these outlines. When you try to look at uh, data pre-processing, we are trying to look at data cleaning. We're trying to deal with the processes of working with format inconsistency, incomplete data, and the challenges that are there with data. That is the most important thing that we are focusing on. Meanwhile, our focus is going to be how we can make inaccurate records from our data to be a little bit accurate. So there are some steps that you need to do when it comes to data cleaning. Don't worry, we are going to do about this logically. Data cleaning. Now, you're going to go with the steps. Okay? The steps, there's several. First of all, is to check. Okay? You need to check for, I'm just going to put all of them here. First, you can check for, you could check for one, which are duplicates. Duplicates. Are there data which are repeated? And when you get data which are repeated, please eliminate duplicate records. You're going to know how to deal with it. Then you're going to deal with wrong format. And then you're going to deal with when you have wrong format, you're going to deal with wrong data. And you're going to deal with empty cells. Empty cells. Sometimes we call them missing data. Now, I want you to be a little bit keen, especially when your focus is going to be on dealing with data. Now, empty cells. How are you going to deal with empty cells? That's going to be your biggest task. I'm not supposed to show you what you should do with empty cells, but it's your responsibility to understand that when I have empty cells, this is how I need to go about working with empty cells. Either you get the mean media so that you can try to, okay, you can try to, I don't like the concept of deleting, okay? But you can do some bit of interpolation so that you can solve some of those issues. All right, now, these are the things you need to focus on. Let me try to explain to you with wrong data. Now, let's say we have age. And in age, your age is 23. Then when you try to look through all the columns of age, and you realize someone is having age of 230. Now, as students, you're going to find that in your data. Now, what is going to come into your mind? Maybe I can listen from you. Can I get some feedback from you before we proceed to another concept? Yes, students, what comes into your mind and how are you going to deal with it? Please make sure you participate so that you make the learning interesting. Hello?
I beg your pardon about the question.
The question is with wrong format. You have age and you find you're looking through the column for age. And where when you're looking at the column, you realize you are seeing 230 in age. What comes into your mind as a data scientist?
I think it can be written wrong data.
Written wrong data.
I would think it would be an oversight.
I think it's wrong format of the data.
An outlier.
An outlier. Okay. Now, I just want you to understand something when it comes to wrong data. Okay? Because many times when you have 230, do you believe that someone can live up to 230 years? That's the first thing that I want you to understand. Please let me explain this so that you understand it all at once. Do you think that someone can live up to 230 years? Say yes or no.
Not
No.
really.
No.
No. So
No,
what do you do?
it's,
What do you deal with such situations? We are not using code. We are trying to deal with the problem as we see. Now, so if you get a data which is like 230, you could use a range and say that most people live between. So anything that is above 130 years or 140, get an average of it. There are several ways how you can deal with it. Okay? You could try to make sure that, okay, when the data is few, you could remove the zero. Is that okay? Instead of having 230, you can use an in-place method and then change the value to 230. But if you have big data and the data is over 1,000, it's not going to be easier for you to see that data that has that what we call wrong data. So what you're going to do, you're going to go an extra mile and put a range. Okay? The higher value. You can say that, like, how long can people live? The highest value that people can live, maybe 150 years. So I will trigger you like in such situations when you're dealing with your final project. In a column of age, I'll try to intentionally put wrong data. I'll try to escalate the figures so that I see how you're going to deal with it. That is with wrong data. Or there are situations where, of course, this can happen because of typo. Or there are situations where I'll try to confuse you a bit. If I have values that are maybe having a consistency of maybe 1.3, 1.4, then I'm going to, these are still under wrong data. Then I'm going to say 150. Okay. I can put 1, 2, 3, or 5. When you try to check is null, it's going to show you that there are no null values. Is that okay? So you need to inspect the data. Now, what you do? So here, what comes into your mind? If the entire columns are having floating points, and then you find an integer value. Okay, what comes into your mind? This should be a typo, right? Now, how do you deal with that? You expect your expectation is that that data should be like 1.5. It cannot be 150. Have you understood what I've said? Hello?
Yes, please.
Okay. Now, so that should be a typo error. And you need to, but if there are very many, since you are doing the project in groups of 4, I can put like 10 of them or 5. I see how you're going to what? How you're going to deal with it. Now, there are also situations of what we call like what we call wrong format. That is with wrong data. Wrong form. I don't want to talk about empty cells and duplicates. That's straightforward. Now we have what we call a wrong format. Now, I will intentionally make sure that some of your data contain a timestamp. And timestamp is, okay. Let me just, okay, timestamp, like time or date. Now, one of the things that I know is that, what's the date of today? Today is what? Let's say today is the 1st of July, and that is 7 of the year 2020. 24. Is that okay? Now, if you have all columns that are consistently like this, then in that column, you end up finding something like 37204. That's why you need to be very keen. What is going to come into your mind? Hello?
Sarong.
Hello, please speak up.
It's an integer.
Okay, it's not an integer. I think it's the date, but it should be the 3rd of July, 2024.
The format is wrong, right?
Yes.
So here you're going to deal with wrong format. And they're not going to be like one. They can be like 3 or 4 of them. But if you notice, such kind of data, to make sure you understand it, we'll try to make sure that that data is a little bit consistent. Like first, second, then you find that data, then you have another data, like which is fourth, 2024. So that will give you an idea of how to deal with the data, right? Are we together?
Yes.
Now, what happens? What happens if you have the following row that follows it, and it is written none, which is not a number, and then the next cell is containing a value. Okay, I don't need to solve the problem I'm setting. Now, what comes into your mind? Please speak about it faster. I want to move to the next item. Because these are the things you're going to find in your data set. Your data set are not going to be very clean like the one we are working on. Explain to me faster. It shouldn't be difficult.
Missing
Yes.
data. It's missing data.
So how do you go about it? Just tell me that it is a missing data. Now, how do you go about it? That's what I want to do. I want to listen to. Yes? How do you go about it?
Excuse me, sir.
Yes.
Is that in the same column?
Yes, in the same column.
Okay, okay. Seeing the way the dates are organized, I think it should be the 5th.
Exactly.
We,
But now,
yeah, replace it with the 5th.
exactly. So those are the things that I want you to look at it in a data set. Do not try to just look at it. Hey, there's a wrong data here. Let me just drop it. No, no, no. First, understand the patterns in it. Is that okay? Because when you drop, your records will keep reducing. In that way, I'm going to get you. Okay. I think we are done with that. And there are others where you can use mean, media, especially if the cells are really empty. Okay. So guys, take note of that. Take note of wrong data. Empty cells are obvious. You can drop it. And then what is going to be complex? Use the mod date to fill in. Yeah. No, there are methods out there for doing that. You can use, there are several methods how you can do it. Especially you need to remove rows with null date, and then you use an in-place method of putting the correct date there. Or if you're going to manually inspect, that is okay. But remember, the data set I'm going to give you is going to be big data. We are working with records that are less than 1,000. But the records I'm going to give you would be like 1,000, 10,000, 20,000. Yes, that is when that's what I'm going to give you. Your records are going to be like 10,000. So you cannot be checking one by one. And I won't put it where you can, even when you scrolling will be difficult because the data will be long. Okay, now I believe I've talked about data cleaning, okay? I want to go logically so that you understand most of those things. Now, once you deal with them, you get done with that, then there are several ways handling missing data. So there are several ways you can remove. If you can't guess the data, please, you can try to do what we call you remove stroke delete. Then another thing that you need to deal with is if you're dealing with some data, missing data, okay, you are dealing with missing data, you can remove stroke delete. You can use what we call mean. This one is called imputation. Imputation, which is basically what? Mean, median, and mode. You already know that, okay? Now, there's another method which I normally like telling people, that there's what they call forward stroke backward filling. You can use what we call forward stroke backward filling. Especially this type of data, we were basically using forward, from first, second, and then here there was nothing. So we kept on moving forward. But there are situations where the data is arranged in descending order. That one you're going to use what they call backward filling. Then the last one, you can also try to use what they call KNN. KNN, or you could use what they call regression. But this is kind of like if you're trying to predict the values using algorithms, then you can use what you call anyway, we are not yet so much advanced with the words. You can use what you call what? Prediction. You can predict the k nearest neighbor. Like if you have data, let me try to have it in terms of consistency. Let's talk about age in your class. What do you think is the k nearest neighbor of the age bracket in your PSC class? The KNN of age in BSE, your class. What do you think? If you find we have 21, 20, 30, no, okay, 29, okay. And if you have age of 12, then you have 19, then you have 41. Aha, what comes into your mind? Please say something. Hello, say something. We go forward. Hello, guys. I told you to be in a place where you can speak. Okay, class rep, Elsa, Nancha. What do you say about that data? What would be the K near? What is the average of the what is the nearest age of each and everyone? The average age of your class, Elsa.
The average of this that you've provided, or
For your class, speak for your class according to how you from how you look at your people that you lead.
20.
Is the demographic 20.
22.
Now, so 22. So anything that is near, like 21, 22, that should be okay. But 45, do you have someone who is 41 in your class? I don't think. Do you have someone who is technically, do you have someone who is 12 in your class? The answer is yes or no. Guys, you need to learn how to answer me.
The
No.
answer
Yes
is
or no?
yes.
No, sir.
No, we don't have.
Yes. Who is 12? Someone is saying yes.
Like,
Who is 12 in your class? And who is 41 in your class? And that is how the outliers start coming in. Okay? So you try to flag some kind of those data. As long as you see something which is outrageous, flag it. Flag it means, you know when you are flagged is that you have created interest in that data and you look at it. So this is what you're going to deal with pre-processing. Guys, I've talked about pre-processing and I've talked about everything. I don't expect anything that you're going to query me when I'm writing my script on pre-processing. Now I'm moving to the next part where I'm going to talk about what we call exploratory data analysis. Now, with the exploratory data analysis, I'm going to talk about, I'll try to talk about maybe a few things so that you understand it. Now, step one, steps. There are several steps that you need to know when you're dealing with exploratory data analysis. Now, this is when you have to go back and bring your knowledge of statistics. Yes or team? Your hand is up.
First, say something small about duplicates.
Duplicates you remove, because you cannot have the same team in a class. If you have the same team in a class, it's going to create imbalanced data. They will affect your data. Empty cells, you can use mean media. But please, I also talked about empty cells that you can what? Delete or remove them. If you're going to remove the data, now maybe let me talk about it briefly. If you have a lot of empty, okay, if you have a lot of records that contains a lot of missing values, please let me now advise you on use mean media mode. Use the imputation method if the values are not very, if the missing values are more than the available data, I recommend you drop that data or drop those columns. Are we together? If you cannot figure out how you can pre-process the data, how you can manipulate it, because sometimes you're going to tell me, of course, when we meet physically, you're going to tell me this data does not have a lot of records. When you try everything, you can't even plot. It's very simple. You can't even do a descriptive statistic. You can't even get the the measure of central tendency, like the mean. You can't even get into the interquartile range. Please, we are talking about statistics. You guys studied statistics, and I think statistics is one of the simplest course unit that everyone has done. So if you have a lot of columns which do not have, if the records that are, if the data that are there and they are missing, please delete them. Duplicates. If you have records that are duplicated, of course, I'm going to intentionally put them there. When you check for duplicates, you'll find them. You just need to drop. You use the drop now to drop the duplicates. Are we together? Aaron, are we together? These are the steps you need to follow, because I'm not going to come back to this. Are we together? Do you now know how to deal with, because by the way, pre-processing is the hardest. Once you get done with pre-processing, the rest are easier. In fact, the exploratory data analysis, you cannot go to exploratory data analysis without doing a pre-processing. So you type 1 in the chat if you are comfortable with data pre-processing, and type 0 if you are not comfortable, so that I see. Okay, Gertrude is comfortable. Okay. Yeah, I'll actually give you a data set to work with. Individual assignment today with a data set. Okay, nice. Okay, I'm going to give you an individual assignment so that you complain and then, yeah, you understand. Thank you. At least I'm happy that most of you are happy with data pre-processing. We are going to do it. We are going to use code and then do that. Something that I expected us to have talked about. Now we are in the exploratory data analysis. Now, to explore your data, to understand your data very well, it is important for us to use what we call descriptive statistics. Remember, I talked about numerical data, categorical data, and ordinal data. I mentioned them. Some of you have forgotten some of those things I was mentioning. Now, but first is that you need to do what we call descriptive, using the describe method. It's what we call the descriptive statistics. Now, here, the descriptive statistics. Now, in the descriptive statistics, I want you to focus and look at what we call measure or central tendency. Of course, this one using what? The describe. You need to look at the mean, the media, the standard. Okay, let's look at the mean, median, and mode. We are going to have it in our next example, all these things logically. Then we can also look at measure of, I hope you're taking these notes, measure of spreads, how your data is being spread in terms of what we call range, the variance, standard deviation, then the interquartile range. Yeah, you need to focus and also look at that. But of course, you use the describe method to look at that. Now that one is going to be done. Please make sure it is in your data. Then skewness, kurtosis, you could go at a little bit advanced up to that level, but whatever, you could look at the skewness or kurtosis. You go and try to expand your knowledge on that. Then you go to what we call data visualization. Now, when you go to data visualization, now you need to focus so much on how you're going to show your data. You can show it in terms of histogram. You could get histogram. And you know, with histogram, it helps us look at the distribution of a single variable. Let's say you want to look at age. So you go with histogram, and then you look at the distribution of age. If you can get a normal, or there's what you call normal and abnormal curve. When you get a normal curve, that means you know the range, the age group. But with histogram, you're looking at a single variable. Then you can use what you call a box plot. A box plot, which is basically for identifying outliers. In fact, box plot is for identifying outliers. You know, when you talk about it, and then histogram, distribution of a single variable. Okay.
Excuse me, sir.
Now, yes.
What does it mean when they say the data is right skewed or left skewed?
No, right skewed means your data is towards the right. Left skewed, it means most of your data are towards what? The left side. And sometimes when they talk about skewness of the data,
Yes.
it's for you to understand the kind of data you have. Let's say you have a value which is a negative and a positive. So if most of your values are to the negative, it shows you the kind of the skewness that are there. If they are towards if the skewness is towards 1, that means you have a good data. If the skewness is towards -1, means you have a wrong data. And why you do the skewness is especially to understand, because you're going to have a lot of, yes, you might have done all those things, but you are filled in, you have tried. Then when you try to look at the skewness of your data, you realize you still have your data will not make good predictions. Are we together?
Yes. So
It is, by the way, it's the same thing.
Is it
Yeah, go ahead.
related to the distribution of the data?
Exactly. Skewness is related to the distribution of the data.
Okay.
Yeah. Please try as much as possible to understand this, because even with the assignment that I'm going to give you, by the way, if you understand this lecture, it is easier. Writing code is not so difficult, because these are the things you will follow when writing your codes. Then you could do what we call a scatter plot. Now, a scatter plot. Now, the reason why we use scatter plot is basically we are examining. Remember the other time we were using it, you didn't know why I was using it, but today you are going to know. It is to examine the relationships between two variables. Are we together? So that's why you use the scatter plot, basically so that you can look at the relationship, especially when you do the scatter plot and then you try to create a regression. You try to draw a linear, try to draw a line in between to help you get to understand the kind of data which you have. Sometimes in fact, that's what we are going to look at: the polynomial, the linear regression, and of course, I'm going to talk about supervised learning and how you go about it. Then I'll talk about unsupervised learning. Then you write the code that does that. I have one example that we are going to use today. Then I have a complex example for you, just for learning purposes. I know you may not pass everything, but you will just try. Then the last one is called what? Heat map. Heat maps. Now for heat maps, basically they're used for visualizing correlation, correlation matrix. There's a difference between matrix and matrix. Please go and read that for yourself. Now, heat map are basically for correlation. And you now understand from your knowledge, from your advanced mathematics of A level, what do you know about correlation? What do you know about correlation?
I think correlation is also about how two variables depend on each other. For example, when you want to, maybe you want to see in case when you change, you make a change in one variable, how will it affect the other?
Okay, thank you. Now, I need to just applaud you for listening up to this point. We are moving. We are not yet done. Now, obviously, you need to also understand if I'm going to do exploratory data analysis, I'm going to do data visualization. What are the tools? What do I need to import? Every time you see import what? So this is what you need to know. Tools for data. Don't worry, we are going to go to future engineering. Okay. We are going to, so what we are going to do here, tools for data visualization. Now, the tools for data visualization are what we call the Matplotlib, the Seaborn, Plotly, and Bokeh. Those are the tools which are there. Okay? So, but you also need to understand when you say import Matplotlib, what kind of graphs are you going to have? You're going to have a line graph, a bar graph, you're going to have a scatter. When you get that library and histogram. Are we together? Are we together?
Yes.
When you write that code, import matplotlib as PLT, so you're only going to have those kind of graph. But if you want to have something which is a little bit having high level interface for drawing and having attractive statistical graphics, then you are going to use what they call Seaborns. So Seaborns are basically used to have what they call, Seaborns has the themes, the colors, color palettes, so Actually, they look more attractive. Looks more attractive. So you remember, I don't know if I could go back to just a second. I don't like people reading my emails. Okay. So if you want to have something that looks a little bit beautiful like this, okay, then you need to use Seaborn. That's why you see I was able to import Seaborn as a SNS. So the reason why, because I wanted to have something which is more attractive, more beautiful, so that I can get the visualization. Are we together? Do you now know why you import Seaborn and why you import Matplotlib? Hello?
Yes, we do.
Okay. So Seaborn is basically, even this beautiful, it looks a little bit beautiful. But this one is, what is this? Matplotlib. I'm 100% sure that that is Matplotlib. Even this one. When you try to check, I have imported Matplotlib as PLT. Very basic. Have you seen now the difference between using Seaborns and Matplotlib? Wait, I'm sure if you plot using, you get something which is more beautiful. Okay. I'm not going to talk about this because they're not so important right now. But all of them are used for plotting. Now, I'm going to talk about something now, which is where you guys started crying. You almost started crying. It is called future engineering. Now, when you look at future engineering, basically here what we are interested in is selection. Now this selection could be, especially on the methods, if you're going to use ANOVA, chi-square, okay? Here, if you're going to use filter methods, like this is just your maths, chi-square, you just need to remind yourself, chi-square, then we call what we also have ANOVA, okay? Then you also need to deal with something called wrapper. I'm not going to concentrate here because most of the time you're not going to find us dealing with it. I want to talk about the next one, which is called future scaling and normalization. You're going to deal with wrappers, and these wrappers can be recursive futures. Don't worry about this, but if our data contains us to use that scaling, then we will go up to it. But for now, our main focus is basically to look at, even you can use embedded Embedded basically use the lasso regression. I'm not going to talk about it, especially that part for now, but I'll talk about this because most of the time we are doing what they call future scaling and normalization. Then please also don't forget that there's another platform called Kaggle. Kaggle is open. In fact, most solutions are there. I don't like to mention Kaggle is because it creates a lot of laziness to the students. When you mention Kaggle, they go there, get solutions and annoying. But I've just mentioned it for you. It's one of the good platform for data sets, solutions, everything. You need to sign up and have an account on Kaggle. I do have an account on Kaggle. Oh, the spelling is here. But thank you, Patricia. It's called Future Engineering. Okay, that's why I didn't mention, I've tried to mention everything for you that you need today. So when you're looking at future scaling and normalization, now, we talked about it earlier. These are dealing with anomalies in our data, outliers, okay? So you could use what we call normalization, so that you now know normalization. And normalization, basically, you rescale them to a range, rescale your data to a range. Like where I mentioned age is the, let's say like age, you can do a range of age. Like in your class, you can say your age should be between, okay, 19, even some of you have refused 19, 20 to at least 25. Okay, let's put 28, extreme. Someone will accept, even you as students. When I tell you, that's why in Uganda here, people don't like mentioning their name. But if you go to the US, they can say, can I have your name and your age, please? I'm sure here people will give you wrong data all the time. You try to ask Nakanwaji Vanessa. Nakanwaji Vanessa, how old are you? So in most cases, they are very relaxed. Now, you see, that's the kind of response you get. You can never ask, in Uganda, can never ask an African lady about their age and they give it to you. Maybe we go to Eritrea and ask Aaron, how old are you? I'll ask also Aaron, how old are you?
25.
25. Is that the correct one? Even foreign people are not very true. Let's try Victoria. Victoria, how old are you? We'd want to go to Chad and see whether the Chad people are also,
I'm
but
23.
I don't. 23. Okay, there's some bit of honesty there. So when you talk about 25, Aaron, it's okay. I have no problem because the data is within the range. But there's a Ugandan who mentioned 33. So in that case, you need to do what we call what? Normalization of your data. The deviation is too big. Normally we use what we call +1 or is it plus 0.5 and minus 0.5. You know that when they're marking you in mathematics. Okay. Then another one, you can use what they call standard standard deviation. Now, when you're using what we call the standard deviation, basically, you can try to transform the mean of your data so that it can contain a deviation of 1. Okay? So you can transform your data to have a SD. You can look at all this data through your what? So you can transform your data so that it can have a standard deviation of any range. You could set a standard deviation that you need. All right. Now, if something is not so unique with your data, then you can go ahead and do what we call you can create new features within your data. Like basically, you can have things called polynomial features. And then you can also have maybe interaction terms for your data. But I've mentioned some, but the one which we are going to use is the one I will focus on. Now let's go to what we call data splitting. Then I'll talk about supervised learning, then we shall look at one example. Now, data splitting. Now, I want to make this clear. Data splitting. If you're going to deal with training, let me just mention, if you're going to deal with training and evaluation of a module, remember, I've not yet even talked about the algorithms. No, I'm still talking about the main thing. If you're going to talk about the training and evaluations of your data, it is always important when you are talking about data splitting to split your data in terms of the training and testing. Now, there are what we call the most common ratios. Actually, most common ratios people use for training and testing their data. Most common ratios. The most common ratios are 20 to 80 or 30 and 70. Now, and of course, you realize that the biggest percentage of your data is being used for what? For training. This is for testing, and then the biggest percentage is used for training. You train modules on large data so that you can get the predictions. Is that okay? And in most cases, you need to use what we call the scikit-learn so that you can implement that training. So always you need to import the scikit-learn, which will help to split your data. This one helps to split the data into some for training, some for testing. So it is going to be the train underscore split, no, test split. So this helps to split your data into the testing. Now, the purpose of it is to help evaluate module performance on data that maybe we cannot see. Are we together? Data splitting, we are going to implement it. When you look at the previous example here, if I can go back there to day 10, Maybe this can also help us move. Okay. Processing. Exploratory, which is okay. Then after exploratory, we now go to, we did some bit of, then we came here to train split. Now, so when you look at this module, like, in fact, even this is basically for, this still can still go for data science projects. You make predictions, that is still okay. Because machine learning, you will use the TensorFlow and the Keras. So now here, what we are trying to do, forget about this line of code, but just look here. From scikit-learn module selection, import train test split. So this is the one which is responsible for dividing your data, and the test size, I told you, you can have 20. But when you're writing it here, you can't just write it 20. The 20 is in percentage. The total percentage of your data is 100. So you need to convert it in decimals, in floating points. So that is, you can use a random state of 1, or you can use a random state of 42. You learn that. But you need to get the data which are using some X data for training and some X data for testing, some Y data for training and some Y data for testing. So that's what you're going to do with what we call data splitting. So this basically is for data splitting. Don't worry, I have a better example. Okay, all the examples are good, but I have something that makes it easier for you to understand. Now, we are done with tests and split for training. Now, we are going to go to another thing.
Excuse me, sir.
Yes, please.
What's the use of the random state?
The random state, let me just get, okay. I am going to explain it to you very fast. Now, every data has what we call the target data. If you're going to train your data, you need to have a target data. Now, if you have a target data where you have 0 and 1, you can do a random state. You can do a random state so that your data is trained on values that do not exceed, it's equal to 1, do not go beyond 1. If you have a random state of data that are very many, then you can even go up to a random state of 42. So it is always important to random state your data. But you could also read more about what we call like random state. Okay? So many times, when you, that's when you're dealing with such kind of data. But sometimes when you try to okay, let's just understand it like this. Random, let me write it. I think it will be easier for you to understand it. Now, random state is used to shuffle the data before splitting it into training set and test set. So random state is used to shuffle data before splitting it into a training and test set. So that answers you. So But of course, that doesn't make you understand. To understand is that random state ensures that the training and the test sets are representative of their entire data set. So that's why when I talked about the target data, so it ensures that the training and the test sets are representative of the entire data. Okay. Now, are representative of the entire data. So let's have a look here. Are you looking at this data set? Hello?
Yes, sir, we are
Hello?
seeing it.
Yeah.
We are seeing it.
Now, with this data, you don't have what you're using it as your target data, unless you random state it. So you see here, we have age up to, so we are using all this data. We are using actually, if you're going to use this target, like 1 up to, then there is this data are being in random state of the target data here. So basically, it is trying to represent the entire data set. So and you cannot find a missing value in a random state, no, in that random state where you're trying to target your data from. Now, there's an example where I gave you in class. I gave you an example of the nice guys. Let me try to also open that. Okay, there's something opening. Okay. Okay. So remember, even when you are looking at this data the other time, I was using have boyfriend to be the random state of our data. 1, 0, because I was very sure that what represents all this data is whether you have a boyfriend or you don't have a boyfriend. I don't care. You can have missing values in number of sibling and what, but I was using the random state that represents the entire data. And that was, do you have a boyfriend? You put 1. If you don't have, you put 0. So random state is basically used for 1, to shuffle our data before splitting it into training set and test set. And it helps also to represent our data. So when we shuffle this data, it will know that those who have contains 1, those who don't have contains 0. And in most cases, you will be using 1 and 0 for representing your entire data. You cannot have a data where you don't have the random state. That can't happen. Okay. So I think that should be good enough for us. Now let's go and finish up this. We are almost closer. I'm not so worried. We are almost closer. We have what you call then, did I answer you? I don't want to pretend like I've answered you or I've not answered you. Are you satisfied?
Yes.
Okay. Okay. Yeah. Thank you. Now we are going to have what we call cross validation. Cross validation. Now, validation is very, very important because it helps us to know the performance of a module. So whether the module is performing robustly. But of course, this can be done by dividing our modules in different folds or multiple folds. Okay? So cross-validation here, in a simple way, or meaning it's just to evaluate the performance of the data. And of course, you can do this into multiple folds. Now, so when you want to give us, the data perform well, you're doing what we call cross-validation. And cross-validation types are what we call, especially for the train and test module, we can use what we call K-folds for train stroke test. We can use K-fold. We can use K-fold, cross validation. Now, you're going to find, by the way, I think I am the most tricky person when it comes to asking. You are going to present your work to me and Livingstone. But I know some of you may choose not to present your data to me because I ask a lot of questions, but that's okay. Go whatever, but I don't like that mindset. And then two, I don't like that stories where people say I don't give marks. I mean, no. When you present rubbish, you get exactly what you, because most people have that mentality that research, I should get an A, I should get higher marks. Then when you start getting 64, you start getting annoyed. Like now, people who attend my classes every day, okay? Yusuf, Rebecca, Stacy, these people are different. They have been here. And if you have been sharing a laptop with someone, this class is, you wait for the time of presentation. Here it is showing me you are 34. You can all confirm. The highest I've had is 38. And me, each and every time you come here, I keep taking screenshots now. And I always tell students, please write your correct name. Write your correct name because you never know. Write your correct name. You never know. Now you are there, you don't want to write your correct name, but you also expect me to what? You expect me to know you. How do I know you? And by the way, and I like giving marks, especially when I'm lecturing. By the time we meet physically, I would have known you from your class contribution, your engagement. And you find that person is having an A. Then for you who never said any word, your mouth has been shut from the start of the, so even you didn't even say good morning. Every time I get here, I ask people, good morning, how are you? Alvin, how are you? Your mouth is ever shut. And I give you a 69. Because I like giving border marks, like 59, 69. Yes, of course, those ones, there are marks where you're going to compete for it, where you're given. Even a group work, you don't get the same marks. Even if you are a group of 5, one can have 80, one can have 90, one can have 70, one can have 60. That is me. Because by the time you come, you are presenting, I expect you pick a part, you say, okay, I'm going to explain on the part of, I worked on data splitting. When I was working on the data splitting, I made sure that I reserved 20% of the data for testing and 80% of the data for training. So according to this, we found out using our cross-validation that our module was performing very well. Why did the model perform very well? We're able to fit. When you speak like a data scientist, say, okay, This one I studied. I give marks. Because there's also marks for oral, especially the oral one is the one I like considering. This one where you write codes in groups and you send me, this one, by the way, and the report. I give marks for report, like 10 marks for report, 30 marks for oral, and you start complaining. Your friend who you think you are better than the friend in terms of reasoning has 80. For you, who you know you are very bright, better than your friend, you have 60 or 70. Because you don't know how to express yourself. This world is all about expressing yourself. I've told you the good thing. You're a very lucky student, by the way. I tell you my expectation. So now let's move forward. I hope you improve. So when you look at the validations, there are two. We can use what we call cross validation. No, the K false, and then we can use what we call stratified. This should just be reminding you of your statistics. Stratified K false. So you will try to see whether we are ensure that most of our distributions are, I just need to write this, ensure our distribution of the target variable. So it's particularly used in the imbalanced data set. So all right, so that's our focus. Now, what are the advantages of these validations? I'm not going to write the advantages. Just know that it reduces the variance in the module, and it will also help us to have a more comprehensive evaluations of our module performance. Okay? You know you like forgetting, but these are the words I expect you when you're explaining to me. Cross-validation helps in cross-validation helps in reducing variance in module performance estimates, and then also provides a comprehensive evaluation of module performance. Now, that is all about how you are going to represent your data. Now, the other last bit of it is what we are going to pick right now, which we are going to talk about it, are the different kind of types of the machine, of the different type of machine learning algorithms. So make sure when you are presenting your data and you're doing all this, the last part which I want to see in your work is the algorithm which is being used. Remember the other time when I was trying to use this algorithm, the KNN, confusion matrix, you told me you are really support vector classifier. You told me you are very confused. You are not understanding. You complain in the comment section. You complain again when I'm first handling it theoretically. But anyway, don't worry. I just like I like making your life to be a little bit better. I may not go into details of explaining everything. I'll just try to mention them so that you understand them. Okay? And I will try my best to make sure that I explain each and everything that is possible under machine learning. So I don't know how best I will be able to have this explained, but let me just start slowly. I hope I will be able to reach there. I'll try to split them, explain them. Yeah, and then you understand. So I need first to break them down so that you understand. First, we have agreed that the machine learning basically have how many types? Who remembers what I said?
Yeah, three,
Hello?
but you may. Hello.
Yes.
Hello.
Yes,
Yes, there are
Yusuf.
three, but you majorly concentrated on two. There is supervised learning, unsupervised learning, and then reinforcement learning.
Yes, the reason why I don't want to do reinforcement learning because it will force me to go into natural language processing. And of course, going into natural language processing basing on the time limit, we may not also do something in web development. Okay? Not that I've avoided it. No. I'll create, if you guys are done with studying this research and you want to continue building your level of expertise in machine learning, data science, AI, then I have a platform which is called a SOM, where you will get all the learnings. It can be video or recorded classes that helps you understand all those concepts. Feel free, continue visiting that our organization, but mainly in agriculture, but I'll try to even move to health. Even today, I've decided to even use an example of health. Yeah, but let's start with the first one. So machine learning and supervised learning. I want first to outline them, the machine learning, so that you understand. No, I want to outline the algorithm called supervised learning. Then supervised learning is learning from a labeled data. Unsupervised learning is learning from unstructured data. Now let's first start from there. Now, I'm going to try to use what I understand so that you also understand it very well. So we have what you call a supervised learning algorithm. Now, when it comes to supervised learning algorithm, if I ask you to make a prediction that it will rain today, we have a lady here who is an expert in weather. What type, if I ask you to make a machine learning algorithm that will predict whether it will rain at 4 p.m., what type of machine learning problem is that one? I'm asking class. If I ask you that it will rain at 4 p.m., if you're to get the choice of machine learning problem, oh no, if you're going to get, the machine learning problem that is there, what kind of problem will that one be? What type of machine learning algorithm problem would that one be? That's a question to you. So you need to first classify. So it's going to be a supervised learning algorithm problem, but what problem? Is it a regression? Is it a classification problem? Because when you are dealing with supervised learning, you're only dealing with regression classification. Okay? And if it is going to be a classification, it will use logic to make the prediction whether it will rain. So that's going to be a logistic regression based on the different factors that make the rain. I'm still waiting for that small right. But anyway, don't worry. I'll make that data. I'll go to a weather station, I think, and get that data. Seems you told me you sent. I'm not sure. One of these days I need to read emails and understand. Okay, so let's do that. So under machine learning algorithm, please sometimes forgive me. I've skipped the spelling of writing correct things here because of thinking and then writing using your hand. So it's quite interesting and challenging. Okay, so we have what we call regression. We have what we call regression. These regressions can be what we call linear or polynomial. Regressions. So if the kind of machine learning problem requires you to do a linear or polynomial regression, especially if you are looking at the age distribution in class, and you may be forced to use linear regression to look at the distribution of age. I'm just giving you one variable. Could not only be age, could even be gender. UBOS came out with a statistic. What is UBOS saying as data scientists and machine learning experts? What is UBOS saying? Please speak up. That's an opportunity. They did actually the same thing we are talking about, data science. What did they say about women? Women and men. So they say that women in Uganda are about 18 million. And men are about 9 million. That means if you're a man, you need to marry 2 women so that you solve the problem. Okay, but what I know is that in Uganda, the population of women outweighs the population of men. Okay, so girls, stop disturbing the young boys of cheating. The problem is your number is very big. Even these days, I see a lot of funny videos of how people are advertising themselves, but it's because of the desperate level. Someone say, just get for me data and buy for me Rolex. I'll stay with you for the whole week. I don't care whether you use my body. The funny things, because of the demographic data, people are really struggling. Gertrude say you can marry 10 and reduce. Yeah, I marry 0. Me, 0. Okay, let's continue. So according to the statistics from you both, it's trying to give us that women are this. And by the way, do you know that the population of our country, majority of you, are between 18 to 30 years? Uganda is such a young population. And it's like a pyramid. There are very many kids in the best year, and people are dying. There are very few people who are reaching 40s. That's very scary. That's why this country has problems. The best generation is that the best is small, and then it should be the inverted pyramid. Like this country called Japan and China. But anyway, I know I'm going to try my best to go to Japan, basically to do some bit of studies. Now that I do global research, international research, I have opportunities where I can have conferences everywhere. I'm so lucky that I'm working so hard to create impact. Now, the next thing that you need to know when it comes to supervised learning, we have what we call regression. The regression can be linear or polynomial. Now, let's also look at what we call classification. Now, classification, don't worry, I will expand on it. Classification problems, okay, classification algorithms can be one, logistic regression. Then we have what we call the KNN, which is the K nearest neighbor. KNN. Then we have what we call the support vector, machine. It's kind of outdated. And then we have what we call decision trees. And random forest. Now, this is what we call classification. Now, I can even ask you a simple thing, especially maybe dealing with something that can push your mind to go an extra mile to understand like decision trees. Okay, it's not very difficult. Now, let me ask you one thing. If you look at the flow chart and you want to look at people based on their nationality, okay? Like here, we have Victoire, we have Aaron. Is there any other international student? And you want to, I will ask you, you want to rank them in terms of, let me use war. You want to rank them in terms of war. We have Eritreans, Chad, and Uganda, maybe another countries. Now, according to you, which people experience a lot of war? Because is that part of the classification type? Yes, because you are classifying them, you're doing what you're making decision. Which people are you supposed to give them the artilleries, the weapons to go and fight? So what about the naive base? Please don't worry, we will reach there. Now, so what happens here is that if the country wants to make decision on what to support, they do what we call this data-driven decision making, based on the kind of before it's either a yes or no. So you can derive that it's a classification problem. I think I may try to see in this way. If you want to understand whether people, how many people love comedy? Let me just try to be a little bit dramatic here. How many people love comedy and they enjoy comedy? Okay, you could type 1 love, 2 doesn't love, 3 doesn't know. You could type in the chat. Okay, you don't know too. All right. Now, if you want to make decision on which program you should put at campus, whether to bring entertainment, whether to bring musicians, whether to bring comedians, whether to bring what else, guys? I'm not so common in that field, eh? But you now go and look at this data. I've just told you to type. So 111. Okay. So now the decision I will come here is that I'll bring comedians because people love comedy. But if I trigger it a bit and say, okay, let's retype this in the chat, and I try to give you the decision I will make on who to bring. 1 for comedians, 2 for musicians. I'm going to put an event at campus. Now, I want to make a decision. You vote. Say 1 for comedy, 2 for music. Type in the chat. So that now I use the data and I make the decision. All right. So the decision tree, I'll look at the flow based on what? Based on the kind of the data you have given me. So I'll draw it in terms of a tree branch. We have 34 students. From 34, 5 said what? Okay, maybe 10, 15 said they want musicians. I draw another branch. This one have this branch. Then I go ahead on that branch of the musicians. Which musicians do you want me to bring before I make a decision? Then you can also type the name in the chat. So I create a branch under musicians. Now I go to musicians. Which one do you want to bring? I create another branch. Kenneth Mugabe. So you start seeing. So now I would pick the musician basing, I would say like, for those who want musicians, maybe 10 people say they want Kenneth Mugabe. So by this choice, I'll now make my decision and say that I'm going to bring Kenneth Mugabe basing on the decisions people were deciding. Have you understood? Okay, so that's how you do the decision tree. Okay? We'll do that practically. Then, I think we are still moving on well. Guys, now I've explained that to you. And by the way, that is actually what happened. Then, the next part is what we call module. After picking the algorithm to use, you can try and see. But here we were trying to look at the performance of the algorithm. Which algorithm is performing very well? Confusion matrix. So we are trying to look at it in terms of the linear, the poly, looking at its accuracy. Okay. Let me get back here. Now you can do what we call module evaluation. Module evaluation. Now, for you to do module evaluation, and by the way, one thing you should know is that when you're looking at the classification problem, you are clustering people based on the decision they are making. Those who said yes, those who said musician, those who said, so that's why it's a classification problem. Even with rainfall, you need to look at the humidity, temperature, all those, you cluster them. Now, when you have done what we call, you pick the best machine learning algorithm that you will use, you need to do what we call module evaluation. And module evaluations includes like metrics. Now the metrics here that you're going to use to pick the module can be in terms of accuracy. Guys, relax with the registration. Okay, let me put the registration link. It's very important. Don't worry, I will have something I'm going to give you that you'll do. It's not also good for me to be the one doing everything for you. You also need to try on your own. Okay, so register here, that's the link. I've given you the link for registration. Please register. Now, what I was still explaining here is that when it comes to evaluating the module, okay? When it comes to evaluating the module, what you need to do here, basically, you need to look at the matrices like accuracy, precision, recall, and F1 score. So this is going to give you, like when you are doing you can also use confusion matrix, precision, recall. No, we can use that. And then we can use the last one, which is going to be AUC and ROC. What is AUC? What is AUC? AUC is area under the curve. Thank you. And what about ROC? What is ROC? Hmm?
ROC is a receiver operating characteristic curve.
Okay, so this is how you do your evaluation. If you're doing the F1 score, accuracy, precision, recall, F1 score, and basing on that, then you can tell us that, okay, we have picked the random forest because its accuracy is higher. This is what we are going to explain. When you look at what we did in day 10, we have the support vector machine, or the classifier, which had the kernels. Then we had what we call the decision tree, which had an accuracy of 9.95. Now, all this accuracy, and then we had also we had also what we call the KNN, which had 0.75. And now we later came and realized that based on this, we have decided to pick this basing on what? The accuracy. So you go ahead and tell us that we are used the classifications of this machine learning algorithm, the KNN or the random forest, because of its accuracy. Now, that's how you do the evaluations of the model. Or you can use the confusion matrix or ROC or area under the curve. That is machine learning. Then there is what we call unsupervised learning. And of course, then you also have to, when you look at advanced topics in machine learning, that is natural language processing or neural networks and deep learning. So neural networks is basically when you're dealing with images, image classification, use the TensorFlow, the Keras, and PyTorch. So all those ones, you can be able to look at it. So I'm not going to go into giving you giving you unsupervised learning problem now. Let us first deal with machine learning problem. No, supervised learning. At least this knowledge is enough for you and it has covered everything. Now, the next thing, if you're going to deal with a data, make sure you follow these steps. Make sure even in the source code, you have what we call data preprocessing, cleaning, reading, all those things. Exploratory data, you have some graphs, you need to do some bit of feature extraction, normalization of your data, splitting of your data, random state, doing all this stratified, and then you pick the machine learning algorithm, test them, and then you do what they call module evaluation. And then you'll come up and make a conclusion statement about that. Any question on machine learning and any question on supervised learning? Now, the next thing that I can maybe give you, which is very, very, very important for you, is what exactly is machine learning and supervised learning in summary. Okay? So, in summary, I can give you here that supervised learning summary is that supervised learning deals with label data, and then also used for predict outcome or output for new inputs. Then the common task of supervised learning. So the common task. So the common tasks are going to be classification and regression. Those are the common tasks of supervised learning. Now, the examples are linear regression, and then support vector machine decision trees, random forest. And of course, how do you do evaluation? You use what they call accuracy, precision, and recall. Now, I've not talked about supervised learning, but I'm going to help you and explain it in summary, is that okay, I'll talk about it briefly. Let me just mention something so that at least when you leave here, you know something. So supervised learning, just a summary here, briefly. Unsupervised learning. It's actually the hardest because it learns from data. So the unsupervised learning basically deals with unlabeled data. The data is unlabeled. Like if you have images of cats, dogs, what? You have not labeled. You want the module to learn from the hidden patterns to understand. So basically here it is to find what? Find hidden patterns. Find hidden patterns. Or structure. In data. Now, are mainly used for common tasks, like what are the tasks? The tasks are mainly clustering, and then we also have what we call dimensionality And then you have what we call association rule and association rule learning. Now, the difference between if you want to understand them by definition, okay, just to give you a little bit glimpse, definition is that when it comes to supervised learning, supervised learning learns from label data to predict outputs and outputs for new inputs. Then for unsupervised learning, learns from unlabeled data to identify patterns and structures within data. Okay, so that's what I can say. I'll talk about unsupervised learning later because the content is too big. But now I believe all of you are on the same page with me. I want to give you a data set that you can try.
Excuse me, sir.
Yes.
I'm getting confused about classification and clustering. To my own understanding, sometimes it's through clustering that we form classifications. Am I right?
Through clustering that you form classification. You see why I reserve clustering is that clustering, we use it for segmentation. Like k-means clustering. So let's do, can we do some small bit of clustering? I want to ask you one thing. What do you like buying in a day or in a week? In a week, what do you normally buy most? Do you buy shoes more than food? Food. So you find if you're trying to cluster, you buy food more. Now, if I ask you, what do you think should be supplied to you most? Money for food. Not so?
Yes.
That's what we call k-means clustering. Okay? Because we are looking at your consumer behavior. How many people like giving their girlfriends money every time? Those one, their classification, their segment problem is different. For them, their happiness is a girlfriend calls, send me money, they have sent. So the parents need to actually give them more money to give their girlfriend. That is how they do it. Because of their behavior, people behave differently. Victoire may be someone. Victoire, what is your most common consumer behavior? Is a foreigner. We are going to get strange answer. Yes, Victoria. What's your most common consumer behavior?
Food, I would say.
Food and sleep. So for Victoria, you need to get for him a mattress. Eh?
I
To
don't
make sure
sleep
that
that much.
no, of course, based on the segmentation of how I'm clustering you. Food and sleep and pillows. Because when you sleep, you need to change your pillow. Pillow
He
if
said I
the
would
pillow
say.
start becoming, I would say, okay. Now let's go and ask these girls. We have heard from men. Any girl there who can volunteer, and then I give you the assignment. I'm going to send it via your email. But sir, you please, Laben, don't go into funny questions. I'm even going to skip that. Please let's go to let's go to another. In fact, delete that chat. Stop asking me about funny things. Ladies, what are your most common consumer behavior? I think, ladies, you tell us. Buying food from fancy restaurants, eh? I know, and taking selfies. So for ladies, they need a smartphone. I don't want to speak for you, but you're forcing me to do a segmentation for ladies. For ladies, good pictures, posting, status. So those are the kind of things. And looking well, dressing nicely. Look well, look good, eat well. That problem is solved. And actually, ladies don't need a lot of money. As long as they have what to eat, they go to fancy places, take photos. So if you're a man, that is what you should look at it in terms of your segmentation. So when you look at clustering, is that you're basing on consumers' behavior to derive the need for goods and services. But you find there are some ladies who are very different. Do you have ladies who are interested who are interested in programming and they write codes throughout? And those ones, you find they even have a very different lifestyle. I'm sure there are ladies who don't lay their bed, don't care. They're not so much. They're not so much into that. All about they care about work. You rarely see them. Gertrude is saying yes. No names. Okay. Yeah. Someone say, yeah, very true, Patricia. I know ladies who don't care much, even how they dress. Some I find some ladies just dress simply, t-shirts, what they move on. Their life. But when you try to complicate your life, buy clothes of 300,000, live that expensive life. You have the biggest problem is sustainability. Is it sustainable? That's why I always tell people dress modest, put on t-shirts, dress simple. Because that's sustainable. A t-shirt is 15,000 or 20,000. Eh? A jean is about 40,000. That's about 80,000. If you buy 10 of them, you spend around 800,000. Hmm? Now I spend now less money on clothes. I stopped the business of putting on coats, suits, what. I do it if maybe there are really, really big events. But most of the time I'm on a vest and a short. And I've turned off my camera. I move to take coffee. That is it. That's the life I live. Most peaceful. So my segmentation is different. So you can do, so clustering is basically grouping. Have I answered you? The last statement should help you a lot. Clustering is all about grouping the similarity.
So meaning clustering, since this is unlabeled data, those groups that are found, they are just clusters. Then classification, since it's already labeled, then we know the class.
Yes.
Right?
Yes.
Okay.
Yeah. Okay. So you find patterns of clustering from unlabeled data. But classification, normally they have the label data, like name, what, there are so many how the classifications are done. Age, their data is already there. But if you want to find age, you have to look for it. You find yourself looking for it. You see this person, then you say this person must be 20. That is clustering. You're doing a segmentation. Okay. Especially in machine learning. Thank you. Any question? Gertrude, you even have trouble with short and vest. Down suit is better. I think, no, yeah. But I think I have problem with vest because I think I normally do like bare chested almost all the time. You're right. I care about few things, but not Adam suit at least. You're right. Gertrude, you're right. I don't like things which give me a lot of hard time. I even hire people to clean my house, washing clothes, everything I hire, I just pay money. The only thing I know, I sit in front of a computer and I'm reading and I'm working to make sure that one day I get a bigger deal. Give us simple jobs. I have. Don't worry, I have. All right. So with all this said, I'm going to send you an email of a data set. Try using this approach. It will be a supervised learning because the data will be labeled. Let me drop you a data. Try it with this. I'm actually going to task you. I'm going to give you a data set. Okay. I'm putting a data set in the chat. Just a second. Just a second. Have you seen the data set? Yeah, that's the data set in the chat. It should give you a little bit of peace. But this data set, do it and finish it today. It's not difficult. Is that okay? Just follow the steps. And upload it to the GitHub. Thank you. So Livingstone told me that I should complete this in 2 weeks so that I give you the project. So I'll try as much as possible to complete. At least I'm comfortable that you guys now have an understanding. And please work on that data set hard. Okay, recording will be available online. If you have not subscribed to the channel, please go and do so. Okay, bye-bye. Any question? Musmenta Masi, I'm sorry I didn't log in on Saturday. I was going to Ginger. So I remember that I was supposed to join you people, but I was already on the way to Ginger. All right, bye-bye. Sir, could you provide us with a Word document so that we can that is me. Those things are for secondary students, my dear. Could you provide this as a Word document so that we can have an outline? No, just go and listen to the recording. I'm sorry. Me, I don't do those. By the way, I stopped.